And then we take all the authorised orders and we bundle them up into a group, and then we ask our suppliers who wants to supply us with this many things today. And then we'll pick whoever is going to give us the best price for the day, and then they ship them to us, and then we ship them to the customer. So it's fairly sort of, there's lots of useful and interesting information here that may be subject to an attack. So things like you can have patient information, their order history. So does everyone understand that context? Yeah, it's just a brief overview.
Is it directly shipped to the customer?
Yeah, we'll ship it directly. So supplier would send it to us, and then we would ship. No, the supplier would send it to us, and then we ship it to them, because we're trying to protect privacy of customers. So we've thought about a bit of it.
Yeah.
However, if you hadn't thought about that, threat modelling hopefully would have made you think about that. But in this respect, I did think about that from. So without going any further, what would be your suggestions on what do we need to secure here? And this is for you to sort of tell me, what would you start with? Yeah? Yeah. So an authorization of the patient. Any others? Well, we probably will authenticate doctors as well, if they're saying yes or no to the prescription. And suppliers, they're going to be getting some kind of information from us, so we want some kind of authentication. So there's a few bits of authentication around. Anything else we need to consider? Patient privacy. So that's going to be an important factor in what we're doing. So yeah, it's going to be sort of a database. What about what kind of technology do you think you would use for this? Based on your current experiences of developing more secure software, what do you think would need to put in place other than some kind of authentication scheme? Yeah, on pretty much everything, I'd imagine. Of course, we have firewalls as well. So, any more? Any more considerations, differences? Okay.
Cryptography.
Yeah, I mean, obviously you've got your transport layer where you're sending information like in HTTPS, that would be secure. We could look at encryption of data in the databases, those kinds of things. Good old password hashing, etc. So with threat modelling, as I said, the first step in threat modelling is really to build a data flow diagram. Now, this tool, and I'm not trying to plug Microsoft, I promise you, this is a free tool from Microsoft called Microsoft Threat Modeling Tool. I find it useful because it draws nice diagrams, but it does some other things which I can quickly cover, but like I said, I'm not trying to teach you this or even promote it. It's just something that's useful for demonstrating. So the idea with threat modeling is you start with a data flow diagram. So it doesn't have to be a detailed data flow diagram. It's just how do we see the data flow through the system? And the level of detail we want to get to is one that allows us to stand up at a board like this and tell a story of all the interactions that are happening in our site at a generic level, without having to say things like, well, sometimes that happens, sometimes it doesn't, or yeah, we need to add something over here that comes into here. You don't need to go into the detail of exactly what the order handler does, but you may want to. It depends entirely on the system. But I think if you're going down more than sort of 2 levels of this, so this is the highest level. In fact, you could probably have a really high level which just says, we've got some external people, they do some stuff and they get some stuff. But that to me is not particularly useful, so I tend to go at this level initially. So the notation, for those of you who are not familiar with data flow diagrams, circle is a process, so it could be a group of processes. An arrow is a data flow. These sort of bars here, that's a data store. It could be all in one database, it could be separate. And these squares, they're external entities, so they're external to the system. There is some different notation that you can use. I mean, I sometimes use stick figures for these, but to be honest, in my experience, the notation doesn't matter, it's the communication we're going to have about this diagram that's going to matter. But I can tell you the story of this, so I can say that a patient sends in some authorised requests. The request handler picks that up. We verify their information through the auth data. We We may update the patient data because they may say, well, I've changed my address. And when they may place an order, we send into patient orders. Use the pointer. Can you see that? Yeah. So that's the patient interaction with the system. We've got a doctor interaction. They send their authorised requests, or whatever they're going to be. We have a handler. It updates the patient orders, so it may say yes or no, or change the details, but we also authorise the patient, the doctor. And that's pretty much at a high level what the doctor's interactions with this are. The supplier, we've got a similar thing. The supplier's here. They get a feed of what orders we're looking to fulfill today, and they can then bid on that. And then they may accept the order, but the order handler pulls information from the current patient orders, which are all the authorised ones, and batches them up and creates an order. And they also check the supplier data to make sure they're authorised. And that pretty much handles what we talked about in the business context that we looked at. Does everyone understand that diagram? So it's a little bit more detail than, yeah, we'll just stick some firewalls here, and we'll have a bit of authorisation. So the point of doing this is that we've got a bit more detailed view of this, and we can start to think about specific threats around the system. An important part, though, of threat modelling is what do we trust? So who do we trust and what do we trust? So a trust boundary is what we want to draw on here. A trust boundary is anything within the boundary, we kind of accept the risks or we just trust those people. Anything outside, we don't trust them and we want to do something different. So that's where authorization comes in, and checking, input validation. But once you're in the system, if we trust two components, trust each other, then we don't worry about it. We just sort of carry on processing through. So in terms of a trust boundary, where do you think we should draw this? Where would you draw a trust boundary? So an easy one is, who don't we trust in all of this?
Supplier.
Yeah, we don't trust the supplier. Who else don't we really trust? When I say trust, I mean we just sort of accept, yeah, you've given us a request, we'll do it.
No kind of usage.
Yeah, I don't trust any users. So my first trust boundary would sort of negate all of these people. I'll draw one on the sec. What about in terms of our architecture? Now, like many companies, we're going to be a cloud company. So this will be one provider. So some nice data storage place, nice and secure. And we'll probably have this on, I don't know, Amazon's cloud or something like that, on the processing. Does that mean we trust data comes from here, between here and here? Should we trust it? No, not really. So we would start to draw some trust boundaries. And this is why I like the diagramming tool. Why isn't it coming up? So you have a whole lot of nice stencils to play with. But we can put a trust boundary in. So we said that we wouldn't trust these people. And we said don't trust these people. And we probably don't trust that lot. So what it means when we've got a trust boundary like this is that any information that we pass between them, either side should be verifying in some way so that they can establish a trust relationship. So within the trust boundary, so in this case, everything that is in here, if they're communicating between each other, they trust each other. So there's no need for authentication between these processes. But between here and here, we should have some kind of authentication. And the same down from here to here. And that's where things like a password field or a password screen. One of the things I like about the Microsoft tool is it does some of the work for us, but it does have some problems. It's primarily designed for a little bit lower level than I like to work, but what it does offer us is some information. So it's already using threat modelling to start to talk about the kinds of threats that we should be looking for. So when we were talking earlier about what controls should we put in place, what is our security on about? You know, I don't think we got 106 threats, did we? We got about 5. So it goes in a little bit more detail, and it needs a little bit more information. You'll see that it's got a category here, and this is part of the Microsoft threat modeling approach. And these are ways of thinking about security between different interactions. So they have this acronym called STRIDE, which is spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. So it's a nice, easy mnemonic to try and remember when you're doing these things. So, I mean, the slides will be available, so you can read these later, but a spoofing is really just an authenticated user, and somehow we're tricked into believing that they are somebody else. But it's not just somebody, it could be something, as we saw between the databases and the processes. They could be spoofed in some way. Tampering is about changing data and affecting the integrity of the data when you're not authorised to do so. Repudiation, does everyone know what repudiation is, or non-repudiation? Yeah, no? Okay. Repudiation is where someone can make a claim and say, I didn't place that order. And if we have no evidence to say, yes, you made that order, then we're unable to repudiate that claim. So it's just a legal term, but it just means that we have no evidence of activities or important activities that someone has performed or not performed. But it's if you get bank transactions on your account, you say, I didn't make that transaction, and they say, yes, you did, because you also made some other ones and withdrawals around that area, so it's likely to be your payment. Whereas if the payment came out in Bangkok and you were in Sweden, they can probably say, yeah, it probably wasn't you, because they've logged information. Information disclosure, the adult friends finder is a classic example of that. It's any threat against confidentiality and privacy. Denial of service, we don't seem to hear so much about that these days, but I'm sure they're still going on. There's certainly a lot of in recent years. And that's really just making a service unavailable for people that need to use it or should use it. And escalation of privilege, the favourite one that hackers seem to want. And that's all about when you have certain levels of privilege, you can either escalate up and have more privilege, or you can escalate sideways to have different privileges that you shouldn't have. And these are classic types of threat ideas that we should be thinking about, or we can think about. But in terms of the data flow diagram, spoofing doesn't really apply to everything, because you can only really spoof people or processes. So you don't have to think one of these for each item in that screen. And that's pretty much what the Microsoft tool has done. Whenever it sees I've got supplier data and I've got a process, there's a threat of spoofing there. So it just generates a threat for you. And as I say, it is just, I would use this just as a guidance, and it gives you a bit of description. So it's good for, if you need to produce documentation, which I generally have to do on our projects for government and banking, this kind of thing is quite useful. And it even gives you some handy-ish hints on what you should be thinking about. But that is, the threat modelling in itself is, you can do it without having this tool, and you can do it without using Stride. And we can see it just goes on and on. So normally, if you just want to go that far, you can just say, yep, that document's probably complete. I'm happy with the story that I can tell at the data flow diagram level. If you trust the tool, that's your threats enumerated. But if you're not using the tool, you may have to find other ways of doing a similar thing, which is why Stride becomes important. So based on this, we've got 106 threats that we might have to mitigate, or at least consider mitigating. So what we then start to look at is this thing called DREAD. I love these acronyms, they're great. DREAD is a process of taking each one of those threats and making a judgment, I would say. It's not a hard and fast rules, it's just a subjective judgment based on your context. So it has a number of components, so damage, so how much impact is that going to have on us? How easy is it to reproduce? How easy is it to actually do this? Do we need special tools that aren't there yet? How many of our users are affected, and how easy is it going to be for somebody to find this problem in our system? And then it basically just has a score, you add them all together, divide by 5, and you get a ranking. Once you've got that ranking, you can order them. The ones that are the highest ranked, you can stop wherever you want. There's no hard and fast rules here. In my case, we generally have to have some measures against all of them. And the kind of things we use, we either mitigate it, so we put a control in place to reduce the risk. It goes away, it just reduces the likelihood or the impact. We can eliminate the threat, and the only way you can really eliminate the threat is take a lot of features out. So, for example, if we thought that having the suppliers accessing our system in that way was too big a threat, we could just take out that whole component and do something different about how we get our suppliers engaged. Or we can transfer the risk, just get some insurance, or blame somebody else, or just wait for it to happen and then deal with it. So, when you look at the threat model that we've got, it kind of tells us some information. That's not one we looked at. But what it doesn't sort of tell us is what's the extent of this problem. How many ways can this happen? We can put a standard authentication scheme in place, but is it good enough? What are the different ways in which that could happen? Because if I think about this in terms of how we authenticate a patient versus how we authenticate a doctor, do we treat them the same? So is a log-on screen good enough for a doctor and a patient? No?
No.
Why not?
Maybe the doctor has to authenticate with another media.
Yeah.
Secure card.
Yeah.
To
So,
say that.
yeah, so if we don't go deep enough, we sometimes make errors in judgment about, yes, we need authentication, so we'll just have a password, a password log-on screen. We'll just build it nice and secure, so it's a good password screen. We'll do the same here, we'll do the same here. But when you start to look into the detail of the threat in terms of things like dread, the impact of a doctor being spoofed would seem to be bigger than a patient being spoofed. Would you not agree? The main reason when you're talking about this in your context is that a doctor can access and update medical histories. He can authorize author medication, but also he can change the medication, which I think that would be scary if someone could go in and just change the medication. You're expecting some heart medication arriving and they send you diabetes medication. That kind of problem will be quite important to catch. But there is a risk here then that that could happen if a doctor gets spoofed. But when you look at the threat models and the ideas that it comes out with, it doesn't always go into that level of detail of how this could happen. So we're going to look at another idea called attack trees, which I use extensively in testing when I'm doing this because they're good fun. And we'll try one now. So if we've got a doctor, this is the threat that we were talking about. A doctor's identity is spoofed, resulting in patient orders being altered. So first question to you all, and this is an interactive bit. How might that happen? What has to be true for that to happen? So an easy start is, what would you need to know in order to spoof a doctor? Based on the idea that we've got some kind of authentication in there.
Username, password.
The credentials.
Yeah. So for them to steal the credentials, what did they need to know? Did they use user ID and password? Here's insert on this thing. How would somebody get a user ID? What are the ways that we know of that someone could steal somebody's user ID?
Guessing.
Guessing, yeah. Any other ways?
Maybe calling to the hospital and asking for the name of the doctor.
Okay, so social. What else have we got?
Shoulder surfing.
Sure, just any more?
Dumpster diving.
You sound like you might have done that before. Just the way you said dumpster diving. Any more?
Network setting.
Yeah. Now, so at this point, when I'm doing this with development teams, they go, don't worry about the network. We're going to use HTTPS. And that's good. You know, it's a good start. So normally what we would do is we'd sort of say, yeah, that's the control that we've got in place here. I'll just leave it at that. And as a tester, the first thing I do is think, that's a test case for me, because I want to make sure you've got HTTP, you actually turned HTTPS on. What can we do about guessing? I mean, when you say, who said guessing? When you said guessing, what specifically did you mean? Just sort of randomly thinking, oh, there's got to be a Dr. Bob Smith.
Yeah.
Yeah.
Your username is your first name or first letter of your first name followed by your last name or something
Yeah.
like a short version of
Using
that.
email addresses, those kind of things as identifiers. So there is another way in which that could happen in this area here about getting a user ID.
You can always user ID in a different system.
Yeah. Any more? Just one really obvious one. You're probably not thinking about it because you've already thought about the control that you would put in place.
How about tools?
Such as,
Tools that are guessing.
so yeah, that's kind of what I was hinting at, is brute forcing. That's what I was asking about, you know, what you meant by guessing. Guessing is kind of like, I'll try this. Brute forcing is just going, right, I'm going to use this dictionary, or I'm just going to start at A and go A, B, C, or A, B, A, you know, that kind of attack. But you're probably already thinking, yeah, we'd have a lockout, a cat lockout on that. So in terms of shared credentials, you know, imagine we thought this is quite important. What could we do about that? So a number of websites that I use all ask for my email address, and being it's a habit that generally people will use the same password related to the user ID that they use. So quite often it's an automatic reaction. Oh, I need a user ID. What's my user ID related to that email, or what's my password associated with that user ID? I think there's a statistic that says like 60% of people will do that, which is quite a high percentage. That's why you end up with situations that, you know, one system gets hacked and the data comes out, and then all of a sudden all their other accounts get hacked because they're all using the same email address and password. So as a control, what could we do?
Don't share.
We could not use a user ID such as an email address. We could just generate a 6-digit number that they use, something like that. So again, we've already started going down into this sort of level of thinking, what are the types of attacks, how would we mitigate it? And these are things that you may think automatically as you're going through your design process, but invariably it's kind of later on when somebody says, yeah, we shouldn't be using our email address here, or an external security consultant comes in and says, yeah, for the patient, that's probably okay, maybe. For the suppliers, yeah, we'd be okay, but for a doctor, that's not going to be okay. We want something a bit stronger, so we could use So non-identifiable user ID, what I mean by that is it's not something that I can easily attribute to you. And that's also an attack against guessing, or a defense against guessing, you know, except that you can then start thinking, I'll just try random numbers, or random user IDs that I think might be related.
So
So-
we have covered the mouse mats, under the mouse mats, no. Because if you start making it complicated
Yeah.
to have usernames, it's gonna be a piece of paper somewhere.
Yeah. I was going to put stupid users, but
What happened with stupid user?
you all know what I mean, so
The doctor can always identify himself or herself with the biometrics, either with the finger or
Yeah.
with the card. And you can eliminate the user IDs that you have to write.
absolutely.
So it can be something he has and something he is,
Yeah.
or she is. But
Or something they know, which is like your password or two-factor, so you can sort of strengthen that control. But the point really isn't, there's lots of things we could do, and I think, in my experience, there's enough ideas about how to protect people and protect data and systems to solve a lot of our security problems. It's just that we're not necessarily given the time or the resources to spend time thinking about it and then implementing it in a logical way. So another way that we tend to use threat modeling, particularly the systems architects and technical architects and solution architects, is to use threat modeling to say, we need to do security because if we don't, this is what could happen to us. And then they tend to start thinking a little bit more about maybe we should. Although that said, some companies, the companies I work for, like a government bank, tend to be very risk averse, so less so. But if you're an eager startup trying to get something out to market quite quickly, you might just say, yeah, we'll take the risk, and we'll deal with the negativity if when it happens. Is there a question?
Do you need to take into consideration like people on the inside?
Yeah.
Is that a threat if someone is like a
So
grumpy and wants to?
The threat model is actually incomplete there, because we've mentioned external entities, but yeah, you're right. There's internal people who has access to these data stores. Is this completely automated? Or do we have somebody who sits here and collects all the orders, pulling off an SQL statement to give a list of orders and keying them in manually, like it's 1980. So yeah, so that's a good idea. But again, like I say, what I'm trying to get across today is really that, when we start thinking deeply, security suddenly becomes a lot more complex and a lot of things we have to start thinking about. But you can build threat models in different ways. I tend to like mind maps because the tools are there to help us do that. Traditionally, they are a tree, but I can never find a good tool that actually gives me trees.
From a user point of view, I'd say that sometimes security actually becomes the vulnerability itself, because it becomes too complicated as a user of using it. So I take the easy way.
Yeah.
That's something I think is an important thing. If it's easy enough but safe, that's good. But it's really safe and unusable, then it's completely unsecure.
Yes, I mean that goes back to the point about usable security. That's difficult to achieve sometimes. And we've already heard, what about the password under the mouse mat or even just on the front of the server, just in case the sysadmins forget. If you make it more complex, lots and lots of passwords for people to remember, it's very difficult. I've got an account with British Telecom as our phone people. I log in maybe once every 6 months to check things, and I need an email address, a password that changes every 3 months, so I have to change it as soon as I go in, and a PIN number which I can never remember, so I have to write it down. And all I'm doing is checking my bill, and to be honest, or paying my bill actually, rather than checking it. So it doesn't feel like I need that level of security for that information. So we've got about 5 minutes. It's gone quicker than I thought. So if you're interested in threat modeling, here are some ideas for you. OWASP, you're familiar with OWASP? Yeah? They've got an interesting page on it. It's a briefish page, so it's quite nice and easy to read and digest. If you're into a much larger, bigger software development lifecycle that you want to implement, there's a lot of information on the Microsoft site. And if you want to start introducing threat modeling into your work, there's a couple of games that are quite good. These are just card games that you can just start using in your team. So one is escalation of privilege. So if you are, it's a Microsoft tool or game. If you want to do things at a little bit lower level, so go down to system level, that's excellent for that. But if you're just doing an e-commerce site, I say just, you're doing an e-commerce site. But if you're doing e-commerce sites, it's a little bit over the top for it. So OWASP have got a thing called Cornucopia, which is another card game that they've created, which is much more geared towards websites, and they're also bringing out one around mobiles and mobile apps. A couple of good books, Threat Modeling, Designing for Security. There is an earlier version or an earlier book by Microsoft, which is a little bit dated now. I prefer this one here. And a newer one, which I think you can get on Kindle at the moment, you can't get it on the hardback or paperback, is Risk-Centered Threat Modeling. That's a big chunky book if you really want to get into the depths of it. So, I hope you've enjoyed the presentation. We've got a couple of minutes if anybody's got any questions. We'll be around for a little while longer, but I do have to shoot off fairly quickly today. So, any questions, anyone? Did you find it useful? Interesting?
Yes.
Okay.
How good is this tool for discussing with non-developers? Like when you want to fight for a two-factor authentication, like
Yeah.
get the money for the project?
So I find that the diagram is good for telling the story about what can happen. But when you start getting into the details of things, people start getting a bit lost in the detail. But the descriptions that they give for each of the types of threats can be helpful because they're written in a less technical manner. It just basically says, this doctor could be spoofed, resulting in this, and this. But it's a good conversation starter. You just have to know your audience and talk to them.
How do you find the interest in different projects regarding this kind of work?
When I started doing this kind of stuff, most of them thought I was crazy. And because I've been a tester, they kind of, it's changing now, but they tend to sort of see you as kind of like, why are you getting involved with design? You're testing. You go design your tests. But I think once you go through, it used to start just getting the development teams into a test design session, and then we talk about this stuff, and they go, "Oh, that looks interesting. Maybe we should do it a little bit before." Just drop those kind of hints. Anything new. I mean, you're all developers, you're all experienced, and I'm sure you're all very capable, and you're incredibly busy. So trying to fit new things into your design process can be very difficult. So that's why I like the games, because they're just something you can have sort of, half hour, deal out some cards and make up some ideas. You get a card that says something like, someone has found a way of guessing the session tokens that you've got. How do you mitigate against that, and what are the threats against that? You just have to come up with it. There's a bit of gamification there because you give a score. You give them a prize, all sorts of things like that. We used to sometimes do this in elaboration sessions on an agile project. Just, they'd come out and they'd talk about all the business stuff, and then we'd have a little game. We'd either draw up a data flow diagram and do that. So it doesn't have to take a long time. It depends how formal you need to be in your context. As I say, banking and business, they're like oodles of documentation, so I just generate most of it and then go on with the testing. Another question?
How sensitive would you say these type of documentations are? If you document your entire data flow and like your threat boundaries, and these aren't like visible or obvious for someone looking from the outside, like how sensitive is it?
Again, it would depend on your context. Most of my work, as I say, is government at the moment, and everything's secret. Well, necessarily secret, but everything's confidential. I would say it's business confidential. It's not necessarily eyes only, I'll shoot you if you tell anybody else or take you to court or something, but putting an NDA in place for anybody who's going to look at it or as an employee, it's less so. But just treat it as any other design that you would have. So if you do other kinds of architecture designs, what do you treat that as? Treat that as the same. Any more? No? Thank you very much.